Good evening, good evening. So this is our function. So they sketched it for you. Oh, I actually sketched it for you, but that's fine. So given this function, I need you to determine the domain and the range. So how do we determine the domain and the range? Well, what is the domain to start with? So you need to know that the domain is all the values of x for which the function is defined. Are you fine? So every time we talk about the domain, we are talking about the values of x that are going to make sure that the function is defined. But if we talk about the range, we are talking about the values of y for which the function is defined. So let's start with the values of x. If you look at this graph, it has the golden arrows there. So what this means is that the function is continuous. So it doesn't end here, it goes all the way to infinity. That's the purpose of the golden arrows. Okay, that's fine. So I also need you to realize that here, this is just where the function is crossing the x-axis at the x-intercept. It doesn't necessarily mean your function is going to stop here. So looking at this parabolic function, you must know that it keeps on going to the right in terms of x values, and it keeps on going up in terms of y values. Even on this side, it keeps on going to the left in terms of the x values, and it goes all the way upwards in terms of the y values. So if you want to know the domain of your function, think of it. It comes from wherever we don't know. It ends where we don't know. So meaning any value of x is going to be defined. So here you'll tell us that the domain is going to be an element of all the values of x from negative infinity all the way to positive infinity. Or if you prefer, you can say x is an element of real numbers because any value of x is defined. You must understand that the function keeps on going to the right, it keeps on going to the left. So whenever you state the domain, you start with a smaller number, you end with the bigger number. So negative infinity is smaller than positive infinity. Okay, that's fine. And this is what you must know. The domain of any parabolic function will always be from negative infinity to positive infinity. That's what you must know. So let's talk about the range then. If we talk about the range, we said we are referring to the values of y for which the function is defined. So for you to determine the range for a parabolic function, you are going to go to the y-coordinate of the turning point, negative 16 in this case. So what are you going to say? You can see that in terms of y values, this function starts at negative 16. But where does it end? It keeps on going up until where we don't know. So it ends at positive infinity. Because if you have a nice look here, you can see that below negative 16, your function is not there. We don't have a function here. So it means the function is undefined at any point that is less than negative 16. So it means your function is going to start at negative 16, then it's going to end at positive infinity. But it starts at negative 16. So you must use a square bracket to show that negative 16 is included. But you use a round bracket for infinity because infinity is not really a number, so you can't include infinity. So you can say it like this, or you can say y is greater or equal to negative 16. Which means the y values are defined for any value of y that is greater or equal to 16. Sorry if I said less than, but it's greater or equal to negative 60. So that's your range. That's fine. Now, this is what I need you to know. If your function is concave, then you are going to have a minimum value. Minimum, think of that. The lowest possible value on your function. You're going to have the minimum value. Now, this minimum value is going to be the y-coordinate of the turning point. That's what you must know. So if I ask you, what is the minimum value of this function? Then you'll tell me that the minimum value of this function, it's just going to be negative 16. So if the function is concave up, you're going to have a minimum value. But if the function is concave down or convex, think of it, convex, then you're going to have the maximum value. Because for the concave up, you are saying it starts here, it ends where I don't know. So the maximum value is infinity, which is not a number. So you can't say you have a maximum value. But if you look at this one, it starts where we don't know in terms of values of y, but it's going to end at this point. So this is the maximum value here. The minimum value is supposed to be negative infinity, but infinity is not a number. So we don't have the minimum value. Yeah, I hope it's a little bit clear. So it's concave, it has a minimum value, no maximum. That's fine. Now I can also ask you, tell me, where is this function increasing and where is it decreasing? So you need to be careful about that. So what do I mean by careful? If you have a look, come to your turning point and make a line. You can see that it's going to be a horizontal line. So this is what you should know. At the turning point, your function is neither increasing nor decreasing. It's just stationary. It's a stationary point, or that's where it turns. So we are looking for the values of x for which the function is increasing. Where is this function increasing? So you're going to look from left all the way to the right. So if you come from the left, you can see that the function is decreasing all the way to the turning point. So at the turning point, remember, it's not increasing, it's not decreasing, but it starts to decrease from negative infinity up until the turning point. So if I want to know the interval of decrease, or rather, where is the function decreasing, then what are you going to tell me? You're going to tell me that the function is going to decrease for all the values of x that are from negative infinity up until negative 2. So what am I saying in short? I'm saying every time you must answer in terms of, or rather answer questions that are saying, where is this function increasing or decreasing? You focus on the x values. But for a parabolic function, you focus on the x coordinate of the turning point, which is negative 2. Because you need to check what is happening on the left of negative 2 and what is happening on the right of negative 2. So on the left of negative 2, you can see the function is decreasing. So meaning all the way from negative infinity up until negative 2, not including negative 2. That's why I used a round bracket. You don't include it because at exactly negative 2, we said the function is stationary. It's neither increasing nor decreasing. So you can say it like this, or you can say this function is decreasing for all the values of x that are less than -2. But if you look on the right of -2, you can see that the function is increasing. Think of that. You can see that the function is increasing. So this function is going to increase from -2 all the way to positive infinity. But if you prefer, you can say it's going to increase where x is greater than -2. That's the interval of increase. Are you fine? Okay. So I can also ask you, think of it, look at this graph and tell me, because the question in the exam is going to say, write down the values of x for which, maybe let's say for which f of x is positive. That's what they're going to say. What are the values of x for which f of x is positive? So if they ask you a question like that, we are looking for the values of x such that f of x is positive. That's how they can ask you. So how are you going to answer that? Remember what we said. We said every time you see f of x, you actually see y. So this question is asking you, where look at this graph and tell us which values of x are going to make sure that your y values are positive. That's the meaning. We are looking for the values of x for which the values of y are positive. So in order for you to get that right, I encourage you to draw vertical lines that's going to cut at the x-intercept. That's what I encourage you to do. Okay. So after doing your vertical lines, you are going to focus from -infinity all the way up until -6 there, because your lines must cut the x-intercept. So if you look from -infinity up until -6 here, what is happening? You can see that the function is above the x-axis. So if the function is above the x-axis, it means the y values of the function are going to be positive. So this means from -infinity up until -6, f of x is going to be positive. So that's the first interval. You tell them that you can either say from -infinity up until -6, or you can say it's where x is less than -6. Either of these notations is acceptable. So that's what you can say. But is it the only solution? Let's check. If you look at 2 there, from 2 all the way to positive infinity, you can see that the function is above the x-axis. So it means from 2 up until infinity, then the function is going to be positive. So you'll say, or where x is greater than 2. So these are your solutions. Any value of x that is less than -6, the function will be positive, or the y values will always be positive. Also, for any value of x that is greater than 2, then the y values will always be positive as well. So these are your two solutions. But now sometimes in the exam, they can say, find the values of x for which the function is negative, or rather for which the y values are negative. So how do you approach that? If you look at this region from -6 up until 2, What is happening there? This is the region I'm talking about. So from -6 all the way to 2, you can see that the values of y, or rather the function itself, is below the x-axis. So if the function is below the x-axis, it means the y values are negative. Are you fine? So any value of x that is greater than -6, but less than 2, then the y value is going to be negative for those x values. So this means that the value of x, or rather these values of x, will be between, because we are saying it's any value that is less than 2, but greater than -6. So at these values, that's where your y values are going to be negative. So I want you to realize that we didn't include -6 as well as +2. So what is the reason for that? It's because at exactly -6, then the y values are going to be 0, as well as at +2. The y values are 0 there. So we are not looking for where the y values are 0. No, we are looking for strictly negative or strictly positive. However, if they had said, find the values of x for which f of x is greater or equal to 0, then you're going to say it's where x is less or equal to -6, or where x is greater or equal to 2. Because here we are now saying two things. We want where it's positive and where it's equal to 0. So at exactly -6, it's going to be equal to 0. But at any value that is less than -6, then the function will be positive. Yeah, I hope it makes sense. I really hope it makes a lot of sense. But if, for instance, they said, what are the values of x for which the function will be less or equal to 0? Then you'll tell them that it's where x is less or equal to 2, but greater or equal to -6. So yes, this is just how you can say, do you include it or you don't include it? It depends on what the question is asking from you. Yes, that's what it depends on. Okay, so let's look at another example. It's not really another example, it's another function we had drawn previously. So that's what we are going to do. So this is another function I've drawn neatly for you. So once again, I need you to determine the domain as well as the range. Tell me if this function has a minimum value or a maximum value. Tell me the intervals of increase and decrease. Then tell me, okay, we'll talk about the inequality questions when we get to them. Inequality questions, I mean, where is this function? In fact, which values of x are going to make sure that the values of y are positive, negative, or what? So let's talk about the domain. Now, I said to you previously, every time you're talking about a quadratic function or a parabolic one, then you should know that the domain is going to be an element of all the real numbers, meaning from -infinity all the way to +infinity. It's non-negotiable. You know it from the get-go because we explained. So what about the range? We said for the range, we look at the y values. But to be specific, we look at the y coordinate of the turning point. So in this case, the y coordinate of the turning point is going to be 25 over 2. That's fine. So we check, where does this function start in terms of the values of y, and where does it end? So we can see that the function comes all the way from negative infinity, but it's going to end at 25 over 2 because there is no function at any point beyond this 25 over 2. So you'll tell them, because we said we start with the smallest value, then we end with the largest value. But because we are saying the function stops at 25 over 2, then we must include it. Include it meaning we use a square bracket. That's what we said. Okay, that's fine. So now that you know your domain and range, I said to you, if your function is facing up, then it has a minimum value. But if it's facing down, it's going to have the maximum value. So in this case, you'll tell them that the maximum value is just going to be 25 over 2. So for the range and the maximum value, you look at the y coordinate of the turning point. Are you fine? So yeah, it's with reference to the y coordinate of the turning point. So we know it's just going to be that much. We don't have the minimum value. It's negative infinity. So infinity is not a number. We can't say anything about it. Okay, that's fine. Now let's look at this function, and then we need to determine where is this function increasing and where is it decreasing. So for increasing and decreasing, we said we look at the values of x. But to be specific, we said we go to the x coordinate of the turning point, because we are going to answer with reference to the x coordinate of the turning point, which is going to be a half. So we go to the half, then we check what is happening on the left of 1/2. So if you have a look, you can see that all the way from negative infinity up until half, your function is increasing. That's what you can see. So you'll tell them that the function is increasing where the values of x are found from negative infinity up until a half. So you can use this notation, or you can say the function is increasing for any value of x that is less than a half. And for your range here, if you prefer, you can say your function is going to be defined for all the values of y that are less or equal to 25 over 2. So these are the alternative notations. That's fine. But now where is this function decreasing then? So if you look on the right of 1/2, you can see that the function is decreasing. So it means the function will simply decrease where x is an element from half all the way to positive infinity. Or you can simply say it decreases for any value of x that is greater than a half. So that's what you can say. All right, that's fine. That's fine. So remember why we don't include the half in this case. Remember that, because we said at exactly half, the function is going to be stationary, neither increasing nor decreasing. Okay. And then I want you to tell me, now we are looking at the inequality questions. So where is f of x greater than 0? So here we are saying we are looking for the values of x for which the y values will be positive. So we said for you to answer that, you need to draw some vertical lines. Still remember that. But we said your vertical lines are going to cut at the x-intercept. That's what we said. So you go to the x-intercept, then you make a dotted line there. And then you go to your x-intercept, you make a dotted line. So you have divided your graph into 3 intervals. So let's look at this interval from negative infinity all the way to -2. So we can see that the graph is below the x-axis, meaning it's going to be, in fact, the values of y are going to be negative. But if you look at the interval between -2 and 3 there, you can see that the values of y are positive because the graph is above the x-axis. So that's exactly what we are looking for. So to answer them, you'll tell them that this function, or rather the values of y are going to be positive where x is less than 3, but greater than -2, like that. Then you'll also tell them that, okay, if for instance, they said, where is this function negative then we said from negative infinity to -2, the function is below the x-axis, indicating that the values of y are negative. So you'll tell them that any value of x that is less than -2, but it's not the only solution, because if you look from +3 all the way to infinity, you can see that the values of y are negative because the function itself is below the x-axis. So you'll say, or where x is greater than 3, like that. So any value of x here that is greater than 3 will make sure that the values of y are going to be negative. But if, for instance, they had said, for which values of x will f of x be greater or equal to 0? So now they are including 0. Then it means you're going to tell them that it's where x is less or equal to 3, but greater or equal to -2. So that's where the function will be greater or equal to 0. The same thing applies to less or equal. Still going to be the exact solution, just that you'll include those solutions, or rather those values of x. And then you're set. So can you see how math is simple, guys? We simplify mathematics. So thank you so much for watching this video. If you still haven't subscribed to my YouTube channel, please don't forget to subscribe, and please don't forget to like this video as well. And we'd really appreciate your input. So please don't hesitate to leave behind a comment. Thank you so much. Let's see you again next time.